In this video, we're going to use our knowledge of transformation to understand the function f of x equals sine 2x. Now we know the function f of x equals sine x. It looks something like this. But what does it mean when we have sine 2x? Okay, so what does this new graph look like? Okay, so from some of our earlier videos, we know that if you have a function, let's say f of x is this function here. Okay, if you have f of 2x, well, we've done several videos on this. This point here will get squeezed inwards, so everything gets squeezed inwards. Even if you're in the negative realm here, it will just get squeezed inwards. So if you have a point here, it will get squeezed inwards. If you have a point here, it will get squeezed inwards. So everything gets squeezed inwards. When you have this 2 here, it will squeeze everything inwards. Now let's look at what happens when you have sine of 2x. So here, this is our graph of sine of x. So f of x equals sine of x. So this is like when x is 0 here, sine of x is 0. When x is 90, sine of x is 1, and so on. 180 is here, so it's 0 here, and so on. Now look what happens when we have sine of 2x. Okay, so when you put this 0 into this x here, it will be sine of 0, because 2 times 0 will be 0. So basically it will still be the same. It will be 0. But when you put 45 into here, let's say we are trying to work out. So our new function is 0 here. Now at 45, well, if you put 45 into sine of 2x, if you put 45 into this thing here, if you put 45 into here, it will be you working out sine of 90, because 2 times 45 is 90. So what goes along this vertical line here is you stealing sine of 40. Well, sine of 90. Well, sine of 90 is 1. So this point here, well, when it's at 45 here, if you put this into this thing here, it will be sine 90. Well, sine of 90 is 1. So this point here moves across here. Okay, and then if you put 90 into this thing here, it will be you working out sine of 180, because 2 times 90, well, it's you stealing this 180 point here and moving it to over here. So this point will be here. So hang on. So remember, this point here moves across here. This point here moves across here. So what's happening is this. This point here will get moved to here. 180 here will get moved to here. So in effect, your graph is being squeezed inwards here like this. So it looks like this. Hang on. So it looks something like this. So this upside down U here will get squeezed inwards. So it will look like this. Okay, and well, if you continue with the same argument, you're going to get something like this. So 360. This is our normal one cycle here. This is our normal one cycle here. Well, this will get squeezed into here. So this is one period here. You see? Can you see that everything's being squeezed inwards? Okay, so our function f of sine 2x will look like this. And it will continue like this, and so on. So it's basically the same thing, but everything's being squeezed inwards here. And then on the negative side, it's also being squeezed in on the negative side. So here, let me give you a comparison here. So this red line here is our normal sine x, and the blue line is sine 2x. Now one cycle of the normal sine x is 360. One cycle is 360. You see this 360 will get squeezed into here. Now can you see that one cycle of the sine 2x will look like this from here. Now this is one cycle. Now one cycle of the normal sine x is this. One cycle of the sine 2x will look like this. So everything's being squeezed inwards. And if you extend it to the negative side as well, everything on the negative side will get squeezed inwards as well. Okay? So this is, well, you can see the comparison here. Okay?